quantum computing. It seems like every time I turn around, there's another headline. Is it sci-fi? Is it about to change the world? I mean, how do we even get a grip on what's real with this stuff?
It's definitely a hot topic. Luckily, there are some clear-headed voices out there trying to cut through the hype. That's where this report from the National Academies comes in.
Okay, yeah, the National Academies, that's about as credible as it gets, right?
Absolutely. We're talking top experts brought together to give policymakers a reality check on where we stand with quantum computing.
Makes sense. Governments probably want to know if they need to hit the panic button or not.
Right. And the report even points out that it's limited to unclassified information, so there's always a chance there's even more going on behind the scenes.
Well, that's a whole other deep dive for another day. But for now, let's break this down. What even is a quantum computer?
It's tricky because on the surface it sounds like just another computer, right? But the difference is fundamental. Your laptop, your phone, they use bits, zeros and ones, on or off, like tiny switches. Quantum computers use qubits, and that's where things get really interesting.
Qubits. All right, this is where I feel like we're about to cross over to some serious science territory.
We might be leaving some folks behind, but trust me, it's worth it. Qubits, you see, they can do something called superposition. Imagine being able to be both a 0 and a 1 at the same time.
Wait, what? How does something even DO that?
It's quantum mechanics. It's a whole different ballgame. Think of it like this. You flip a coin, heads or tails, right? But while it's spinning in the air before it lands, it's kind of both at the same time, at least in a way. That's kind of what a qubit can do.
So the qubit is like the spinning coin, holding both possibilities until someone, measures it.
Exactly, and here's where it gets really wild. When you add more qubits, you don't just get a little more power, you exponentially increase the possibilities. 2 qubits, 4 states, 3, 8, and it just keeps going.
So more qubits, exponentially more power. We're talking about levels of computing power we can barely even imagine.
You're getting it. And this isn't just about being faster. It's about being able to tackle problems that would take a classical computer billions of years, literally. Problems in medicine, materials, even breaking codes, stuff that's just impossible right now.
Okay, now you're talking my language. So it's not just speed, it's the kind of problems you can even attempt to solve that changes.
100%. And then on top of all that, there's something else. Entanglement. 2 qubits linked, and when one changes, the other one changes instantly. It doesn't matter if they're a mile apart or a million miles, it's like they're telepathic or something.
And entangle. Okay, yeah. We're officially in sci-fi territory now, though this is all supposed to be real, right?
As real as it gets, and this report gets into the weeds on this stuff. But they also break down that there isn't just one kind of quantum computer. You've got analog computers, like what D-Wave makes. They're great for certain tasks. And then there's the digital ones, more like what we use every day, just way, way more complex to build.
Okay, so different types of quantum computers, each with its own strengths and weaknesses, and this almost unimaginable power. But if this report is for people making big decisions, I gotta ask, what's the holdup? Why isn't everyone scrambling to get their hands on one of these things?
Yeah, it's a fair question. And to be honest, the report doesn't sugarcoat it. Building these things is hard. It's one thing to do it in a lab, but to make one that's stable, reliable, that's a whole other story.
So what's the biggest hurdle? Just cramming more qubits in there.
If only it were that simple. One of the biggest challenges is something called noise. Qubits, they're incredibly sensitive. A tiny change in temperature, a stray electromagnetic field, even vibrations. It can all mess with those delicate quantum states and cause errors.
So it's like trying to, balance a house of cards in the middle of a hurricane.
Pretty much. And that's why researchers are working so hard on error correction, ways to compensate for the fact that these qubits are just inherently fragile. But it's a huge challenge.
Sounds like building these machines requires insane levels of precision. But let's say, just for a second, that we figure it out. What changes? What does a world with quantum computers even look like?
It's hard to even wrap your head around it. Take cryptography, for example. Right now, our online security depends on math problems that would take a classical computer, even a supercomputer, thousands, maybe millions of years to crack. A quantum computer, the right one, might be able to do it in hours.
Okay, now that's both exciting and terrifying at the same time, like giving someone a skeleton key to every secret on the internet.
Yeah.
But surely there are more, let's say, positive applications.
Oh, absolutely. Imagine being able to design drugs and therapies tailored to someone's specific genes, simulating how diseases work at a molecular level, maybe even understanding how consciousness itself works.
Personalized medicine, unlocking the brain. Yeah, we're talking high-stakes stuff here.
And that's just the tip of the iceberg. Quantum computers could revolutionize how we design materials. Imagine lighter, stronger, more efficient materials for everything from energy to transportation. It'd be a whole new world.
So we're talking about a materials revolution on top of everything else. What about artificial intelligence? Is this the key to finally unlocking true AI?
It's definitely a possibility. Quantum machine learning, where these algorithms can analyze massive data sets and find patterns that would be invisible to regular computers. It could mean breakthroughs in how we do image recognition, natural language processing, maybe even create machines that are truly intelligent.
So not just faster AI, but smarter AI, something that actually understands the world the way we do.
Well, it's a lot to process.
And it's not just about making what we already have better. Quantum computing could be the key to solving some of the biggest mysteries out there, like the fundamental laws of physics, simulating how complex systems like the stock market work, even predicting earthquakes. Okay, we've gone from breaking codes to predicting earthquakes and understanding the universe. This is definitely not your average computer upgrade. So much to think about. But even with all this potential, this report isn't just about building bigger, faster machines, right? We need the software to actually make this stuff work.
You're absolutely right. Programming a quantum computer, it's not like just tweaking some code for our laptops. It's a whole different ballgame. And the report really stresses this. We're talking new programming languages, algorithms, a whole new way of thinking about software.
So it's not just about the hardware catching up. We need people who can even write the rule book for this new quantum world.
Exactly. And it's not something any one person or even one company can do alone. The report highlights that this is a global challenge. You've got the US, China, the EU, they're all pouring resources into quantum software developments. It's like a whole new space race.
Speaking of races, one thing that keeps coming up is this idea of quantum computers breaking encryption. That's a little unnerving to say the least. What does the report say about keeping things secure when these machines are out in the wild?
It's definitely a concern. They talk about the need for what they call quantum-resistant algorithms. Basically, we need to invent ways to encrypt data that even a quantum computer can't crack. The good news is there's already a lot of research going on in that area.
So it's like we're trying to stay one step ahead of the very technology we're creating.
Yeah, in a way. And the report makes it clear moving to a truly quantum-secure internet, it's not going to be easy. It'll take time, effort, a lot of coordination to upgrade systems and make sure everything still talks to each other safely.
It sounds like the future is being written right now, one line of code at a time. But we've covered a lot of ground here, and I think it's important to step back from all the technical details for a second. What about the ethics of all this? Who gets to decide how this technology gets used, what's off limits, all that?
You've hit on a crucial point. As we go further down this road, we have to be asking those tough questions. It's not just about what we can do with quantum computing, but what we should do. There's a lot of responsibility that comes with this kind of power.
It's a good reminder that even when we're talking about physics that sound like science fiction, the biggest choices are still about how we, as a society, choose to move forward. Well, I think we've given everyone a lot to think about today. Quantum computing, the science, the potential, the challenges, even the ethical questions. It's definitely more than just a tech upgrade, that's for sure.
It's a whole new world, and we're just starting to explore it.
And on that note, we'll leave everyone with this. In a world transformed by quantum computing, what role do you want to play? That's something to ponder. Until next time, keep exploring.